Hi everyone, and welcome to HashiCorp Global. I am Elif, and today we will discuss about the approaches of deploying Consul in heterogeneous workloads, mixing virtual machines and containers, especially in the context of many companies moving away from legacy applications to microservices. And of course, infrastructure needs to be a pillar within this movement. Let me quickly introduce myself. I'm a DevOps engineer with experience in infrastructure administration, optimization, and management. I've been working with HashiCorp tools and technologies for over 3 years now, helping clients ramp up the transition from, let's say, traditional infrastructure to either hybrid infrastructures or even fully in the cloud. I'm quite happy to say also that I'm one of the co-organizers of HashiCorp user group in Bucharest. And nonetheless, I'm quite happy to collaborate with communities into driving technical excellence and nonetheless having a cup of coffee with my peers. Today's talk is structured as follows. Firstly, we'll take a look at the status quo in the industry. Next, we'll cover what Consul is from a bird's eye view, and then deep dive into deployment strategies and the manner we are able to deploy Consul in hybrid environments. Nonetheless, we'll explore in detail one of these aspects in the hands-on bit. Okay, so what's the current context in the IT industry? According to the most recent studies and analyses, the global cloud microservices market is expected to rise at a considerable rate in the next few years. The surge in the volume of enterprise data, rising automation of business processes, and the growing digitalization are the major drivers for the software market. Microservices have been making waves for the past decade. However, what are microservices? These are based on development of separate programs providing services. Each of those can move and scale independently of other programs existing in an ephemeral way. Moreover, the adoption of this paradigm has led to the rise of containers and container orchestration tools such as Kubernetes and HashiCorp Nomad. And the game has changed. But why is the question? Firstly, let's quickly take a look at DNS. At that point, the traditional DNS-based service discovery was no longer enough. In order to be able to continuously support the operation of services, developers and development teams needed more and more networking features in the areas of security, traffic control, reliability, and nonetheless observability. Additionally, the number of applications deployed each day was increasing dramatically. It was getting really cumbersome to include all these capabilities within the application code. Then Kubernetes appeared into scene, and it did try to address some of these concerns. However, it still has some limitations. I could mention some of these. For example, Kubernetes does not check if a service is healthy before trying to communicate with it. It does not encrypt communication between services, and I would dare to say that it is not mature enough when it comes to scaling up or removing pods, and by that I mean scaling down. This might be the moment when you are talking, oh, what is she talking about? Is this presentation suitable for you? Well, I'd say yes, because we are witnessing the transition and the adoption from classical infrastructure to other types of infrastructure alongside the manner applications are developing. I'm most certain that some of you have faced such issues. The question is, what is the best approach to do so? Because we want no service interruption, we want no data loss, and we still want to be able to deliver the best service to our clients. It's not a shift and lift effort. It should be a smooth transition. And this is where Consul comes into scene. And this is how we start discussing about the beginning of service mesh in hybrid environments. Following the industry trends, the developers of Consul have released in 2018 a fully fledged service mesh, and that is Consul Connect. Consul Connect enables a Kubernetes cluster to securely communicate with services outside itself. Connect enables communication between a sidecar proxy in Kubernetes in order to reach an API gateway surrounding standalone databases, virtual machines, and even across different clouds. So, since we are talking about Consul, the next natural question would be, what is Consul and what does it do for us? Well, Consul is a service networking solution. It is aimed to automate network configuration, discover services, and enable secure connectivity across any cloud or runtime. What's really interesting about Consul is the fact that it takes a different approach to networking. And how? It provides a central service registry. It enables service discovery in order to allow services to register themselves, discover, and connect with each other directly. It enacts a service mesh solution in order to simplify networking by shifting naming abstraction, routing, authorization from central middleware to the very endpoint. It drives automation to eliminate the operational burden of updating networking middleware. And let's not forget the fact that Consul is platform agnostic. This is what makes it a great fit for any environment, including legacy ones. Consul can be used alongside virtual machines, containers, and container orchestration tools. And we'll keep this in mind because we'll come back to this and actually see how this is done. I was telling you before that Consul Connect was released in 2018. Let's quickly take a look how it has evolved ever since its birth. Up to this moment, Consul Connect was released in the version 1.2 of Consul. Up to that point, Consul was primarily known as a service discovery tool. However, starting that moment, it provided all the components of a fully fledged service mesh, such as automatic traffic encryption, easy communication rules by creating intentions. These allow or deny service communication. Later in 2018, as you can see in the timeline, the support for Consul in relationship with Kubernetes has been considerably improved by adding several capabilities, such as service catalog for syncing Kubernetes services to the Consul catalog and vice versa, the release of the official Consul Helm chart for running and configuring Consul on Kubernetes, Kubernetes autojoin, and many more. Later in 2019, we noticed the release of the Kubernetes authentication method type. This is the moment when applications actually living in Kubernetes became able to authenticate to Consul natively. Next years, Consul continued to evolve and several features were added. Okay, and however, how does Consul work now? This would be the next natural step into taking further. The core process of Consul is its agent. This can be run in either server mode or client mode. The servers, are responsible for storing data about the services that are running, their configuration, health statuses, and much more. A production Consul deployment would typically run 3 or 5 Consul servers. However, for development purposes, as you'll further see, one server should suffice. Multiple servers are run in order to ensure data persistence and high availability. Should one server go down, the remaining ones are still able to service requests, and very importantly, there is no data loss. In contrast, clients are responsible for detecting the health of services running on their nodes and the health of other nodes in the data center. These clients send the information to the servers so that their catalog is kept up to date. We've seen what Consul is. We've seen how it works. Let's see how we start using it. Before deep diving into Consul deployment strategies, let's clarify what actually a deployment strategy is. In a nutshell, deployment strategies comprise of a set of models and practices which enable the release and update of an application in a quick manner. Let's translate this to our topic today. This means that we are going to explore how to deploy a Consul data center in a hybrid environment. By hybrid environment, I understand the mix of virtual machines and Kubernetes. The virtual machine could be either on-premise or in any cloud provider. Also, the Kubernetes service could be either on-premise or one could use any managed service from any of the major cloud providers. So there would be 4 possible combinations. The first case would be discussing when clients are running on non-Kubernetes nodes and these join a cluster which sits on top of Kubernetes. In such a case, we need to ensure that the pod's IPs of the clients and service in Kubernetes are routable from the VM and that the VM can access port 8301, guess what, that's for gossip, and port 8300 for RPC to those pods IPs. Moreover, it may seem obvious, but however, I need to mention, unless using mesh gateways, we also need to ensure that the IP address space do not clash. That would be a major networking issue. The second case would be when the Consul servers are running on top of VMs and the clients are joining the data center within Kubernetes. In order to use an existing cluster to manage services in Kubernetes, clients can be deployed using the Helm chart. This design allows Consul tools such as Consul or Consul template and others to work with Kubernetes. We're running Consul as a pod inside of Kubernetes. The servers will automatically be configured with the appropriate address. However, when running Consul servers outside of the Kubernetes cluster and clients inside Kubernetes and pods, there are additional networking requirements one needs to take into account, and therefore I would highly encourage you to check the official documentation before starting the design. The third and last case would be the time when there is a single Consul data center that spins across multiple Kubernetes clusters. Pay attention, there would be one cluster which has both servers and clients, and the others would be joining only as clients to the data center. In order to accomplish this task, I've broken it down into different steps. The first one would be the actual setup of the Consul server using an Ansible role. The second side would consist of performing certain actions on the Kubernetes cluster so that this is able to authenticate with the server, and we'll use the Kubernetes authentication type I was mentioning before. For the first step, I've chosen Ansible in order to install and configure the Consul server because automation makes sense in terms of Consul deployment strategies when configuration management is involved. As you already know, Ansible is an open source tool that automates provisioning, configuration management, application deployment, and many other manual processes. One key benefit is that Ansible provides is that its modules are independent. This means that we are interested in the end state, and no matter how times we are performing those actions, the result will always be the same. How is this actually done? Let's quickly get it. In order to install and configure Consul, we need to perform certain actions on each of the nodes. The first one would be we need to determine which Linux distribution we are using. Second, we need to add the repository in order to be able to download the Consul binary. In order to install and configure Consul, we need to perform certain actions on each of the nodes. The first one would be determining which Linux distribution we are using. The next step would be to add the official repository in order to be able to download the Consul binary. Thirdly, we need to add the Consul user group and create all the associated directories. We also need to copy the configuration file we have customly defined, and in the end would be starting and enabling the Consul service. Imagine I'm using for the moment a single server. What would happen when we would need to configure 100 or even 1,000 servers? This is the magic of Ansible when everything is beautifully automated, I would dare to say. The next step is to take a look at what happens on the Kubernetes side. In order to set up the Kubernetes cluster, we'll perform the following actions. The first one would be setting a Kubernetes service account in order and assign certain privileges within cluster for this so that Consul is able to authenticate. Next would be setting up the Kubernetes authentication method, installing the agent and connect inject, and in the end confirm everything is working as expected. Let's break it down. Firstly, we need to create a service account and assign certain cluster role privileges, and of course create also some cluster role bindings for Consul. Look at the code snippet, you'll notice something interesting. And I also need to mention that I've used for this demonstration Kubernetes 1.24. And what you need to take into account when using this version is that starting with Kubernetes 1.24, service account token secrets are no longer automatically created. This means that we need to manually create the secret, and the token key in the data field will be automatically set for us. So beware of this small detail. Next. Well, we are creating an authentication method. There are two prerequisites for this step. The first one would be the fact that we need 3 information exported from the Kubernetes cluster. As you see, I'm using the JVD token and also the CA certificate, which I've extracted from the Kubernetes cluster. And as you see also, there is a Consul ACL. This means that for the Consul server, I have already enabled ACL. In case you don't use ACLs, which is discouraged in my view, pay attention also to this. And well, we are almost there actually. The picture looks nice. However, before that, we also need to install the Consul agent and connect inject using the official Helm chart. In this case, Consul will run as a daemon set. This ensures that there is a pod on each of the nodes comprising the cluster. Connect inject, on the other hand, will be a single pod deployment. And this is how everything looks like. As you can notice, the Consul server has a public IP address. Well, the name is not that happy. However, notice that on the side of the Kubernetes nodes, there are some IP addresses which are private. Okay, we now have a Consul server sitting on a VM and a Kubernetes cluster of 4 nodes who has joined this data center as a client. This is an example of using Consul in a hybrid environment. I have chosen, out of the 3 deployment strategies I have talked before, I have chosen this one in particularly because usually companies and large clients are transitioning from an infrastructure of VMs to microservices sitting on cloud or sitting on Kubernetes mainly, regardless where Kubernetes is. This is why I think this example might suit a great many deal of us. However, what's next? We do have a data center. We do have Consul joining the cluster. What should we do next? Well, Consul Service Mesh offers a flexible and comprehensive set of service discovery and traffic management features at layer 7. The service discovery process can be thought as a discovery chain which passes through three distinct stages actually: routing, splitting, and resolution. Routing would be the first stage of the Layer 7 traffic management pipeline. This allows the interception of traffic using Layer 7 criteria such as path prefixes or HTTP headers. The next stage is the service splitter configuration. This allows the splitting of incoming requests across different subnets of a single service or across different services. And the final stage is, of course, the service resolution configurations. This allows for defining which instances of a service should satisfy discovery requests for the provided name. Well, I would sadly say that this is the end, but we are not quite there. We have discussed today about how the industry is shifting from traditional infrastructure types and how infrastructure is supporting development process into adopting a microservices-oriented paradigm. Do not underestimate this effort because it's quite heavy. Infrastructure people and development people need to work together. I've chosen Consul as an example of aiding this transition in order to ensure a smooth movement. We did look into what Consul is. We did look at how Consul has evolved for the past years, what problems Consul is trying to address, and how we are able to leverage all its capabilities. And also stay tuned. I'm quite sure Consul will evolve nicely. Thank you, everyone. I hope you enjoyed this presentation, and thank you for having me at HashiCorp.